Next is process description. Processes and resources. So there is a virtual memory and you have computer resources. There is a process 1, process 2 and likewise there are n processes. So suppose this is the description of the process. Suppose the process is at 8003. Now there is an input output request given to the process. Suppose you need input from the user, 2 numbers input 2 numbers. So the process will now stop its execution at 8003. Which process? Process B. From 8000 it came to 8003. Where it was? It was in its running state. See this. It was in its running state. But because of certain input output request, it had to stop at 8003. So at this position, where it will go? It will go in the waiting state. When it goes in the waiting state, what happens? The dispatcher will come and a new process will be started, that is process C starts. Okay, so here you have the process number C which starts. Again process C will be timed out because of some reason, and which process will start? Process A will start. Process A. So let's see what is happening in this. Okay, let's see first. So first you have the process A which is starting 5000, 5001, 2, 3, 4, 5. 5005 process A ends. And what happens? There is a ready queue. So this is process A. Process A goes inside the ready queue. From the running state, it will go inside the ready queue. Now, which process will start? Process B starts. Process B will start. So there is process A, there is process B, there is process C inside the ready queue. So process B will start because it is second inside the ready queue. It will operate till 8003 and then there will be an input output request. Say there is a user input request. The user has to input 2 numbers. So again this process B will stop and it will go inside the ready queue and process T starts. So which starts? Process C starts. Now process C is not in the ready queue. Process C is running. Process C will run till to 12,005 and then timeout. That means process C will also stop. Now again process C will go inside the ready queue and process A. So we will start with the first process again. So process A will come out. Process A will operate. It had stopped at 5005. So from 5006 it will start 7, 8, 9, 10, 11. Again because of some user input file, because of certain request, input output request, user request, again this process will stop. Process A will again go inside the ready queue. Then process B will start. So process B will not be in the ready queue, it will be in the running state. 12 and it will operate till 12:011 and then it will be timeout. Again this process B will go in the ready queue. This how the processes operate. So first process comes in. If there is a user request, then this process will go inside the ready queue and the second process will be given a chance to go in the running state. Again the second process, when the second process will become timeout, again it will go in the ready queue and the third process will be given a chance to enter in the CPU. This way the things will function. General structures of the operating system control tables. There is memory, devices, files, processes. Memory has memory tables, devices you have input output tables, files you have file tables, processes will be 1, 2, 3. So there are many processes, n processes are there. So what are memory tables? Memory tables are used to keep a track of both the main, real and secondary virtual memory. Some of the main memory is reserved for the use by the OS and the remainder is available for the use by the processor. So there are two memories, main memory and virtual memory. So some of the main memory is reserved by the OS and some is used or is available to the different processes. Processes are maintained on the secondary memory using some sort of virtual memory or simple swapping mechanisms. Input-output tables are used by the OS to manage the input-output devices and channels of the computer system. At any given time, an input-output device may be available or assigned to a particular processor. If an input-output operation is in progress, the OS needs to know the status of the input-output operation and the location in the main memory being used as the source or destination of the input-output transfer. So, location should be known to the OS that at which location a input is required. So, suppose it is a C program and all the program files are present in the C drive. So, the location is C drive. So, OS should know this location and also should know that which program needs the input so that it can give this input output operation is in progress. The OS needs to know the status of the input output location and the location in the main memory. So once it comes to know the location in the main memory, what happens? It does the IO transfer. File tables provide information about the existence of a file, their location on secondary memory, their current status and the other attributes.